forward is our origin, and this is our pole. So because this origin, we just keep the name same. Okay, and then there is something which we have just now spoken. So we've got a directed line segment. This line I'm going to be calling it initial line. Okay, so we have got a pole and the initial line. Here it is a straight line, so you don't worry about my sketch here. Now what happens as this initial line, okay, this initial line is revolving around and coming back. Yeah, so we are having a so this is now, since the starting you go anywhere, let's see here. Your initial line has come from there to here, and it is making an angle. So this theta and this is r. Okay. Now this is what is meant by r and theta. So here, if I have a point here, this point I will write down as r theta, because its length is, let's see that this is the radius vector, isn't it? This is always going. So when you got, you got the sketches, something like this will be coming, something like this will be coming. Now, if you see that your r at different places has got different lengths, isn't it? So it is not, this is your r, this is your r at this stage, this is your r at this stage, this is your r at this stage. So it means that your r is not a constant. Yeah. So now when you got initial line, so what we do is, the next one we will talk about it. We got this line, this is, so I'm going to call this as theta equal to phi. Yeah. Yeah, so this one. Then as usual we go here, then this is theta is equal to phi, and this one we can use it whatever we are using it accordingly. We are going to be writing this as theta is equal to minus pi by 2 or minus pi by 2 or 3 pi. Depending upon what angle you are measuring in, what is the range of value of theta. So here when I have got initial line at this stage, my coordinate, my point is r and 0. So at this point, my coordinate will be r and phi. My coordinate here will be r and minus pi by 2 or 3 pi by 2, whichever measurement you take. Yeah. Then you see that here the angle is to be measured in anti-clockwise direction, because angle, this will be the positive angle. This is again the same ruling that we got as we did in XY. Is all okay? Hello?
Not really, doctor. I'm a bit confused.
Okay,
Doctor,
just
can you use a pointer? Can you use a pointer while explaining, so like we can know which part you are referring to?
Yeah, because your drawing is like lagging, and then your voice is like,
doesn't seem.
yeah.
My voice?
Yeah, no, your voice is faster than the drawing.
Yeah, so we don't really understand.
Okay. Now you can see the board, right?
Yeah.
Yes.
You can see.
Now what I'm telling you is, let me just tell you again. Here, this is your origin, which we call it as pole. Okay. This is our initial line. So this is the polar coordinates starts with this. So far so good.
Wait, where are you referring to?
Sorry.
Which part are you referring to?
No. I'm just starting from starting.
Oh, okay.
What is moving these figures? What is moving the figures? The polar coordinates start with needs to have the main. See here, when you got x and y, when you got x and y, what means you got x and y? That means you have got x coordinate and y coordinate. That means you got this, you got this, you got this, and you got this, you got this, you got this, you got this, right? So you got to have x-axis, y-axis. You need to have a point. That means you need to have the distance on x-axis or parallel to x-axis, and distance on y-axis or parallel to y-axis, right? For the polar coordinates, what you need to have is, you need to have a r and a theta. So theta is the angle made by the initial line with the pole. Is that okay? And r is the length of the rope. Let us say it is because we got a fixed pole, we got a rope is there, so we are pulling that rope from the pole, so that length of your rope is r. Okay? Are we okay with this? You have to tell me yes, no, then I can proceed to next. Are you still not able to hear me or understand properly what's happening?
I can hear you.
I think it's a mixture of both. I mean, we can hear you, but I don't really know what polar coordinates are. Are they just coordinates on a circle, or?
They are coordinates like x and y. Now, to find out x and y, we have the x coordinate to be measured along x-axis or parallel to x-axis, right? Yeah.
Okay.
And for y-axis, either parallel to y-axis or on y-axis. So that when we know the distance, let us say 2 and 3, then we measure two units from 0 to on x-axis, and from there we can measure 3 units around y-axis or parallel to y-axis, and we can fix the point. Is this point okay? If I say
Yeah. I think. Yeah.
Now what I'm going to tell you is that I am going to be writing this point as r and theta. Okay. The same point I'm going to give a different name. But what is r and what is theta? What is r and what is theta means here? I join this here. And this is my r and this is my theta. Now we have got a different measurement, isn't it? if I know the length of R and I know the angle that it is making with the x-axis, can I not plot the point? Yes or no?
Yeah.
Now, what
Right.
happens here is, instead of, see here, instead of x-axis, we are going to call it as initial line. When x-axis, the positive x-axis is your initial line. Then you got 90 degrees. When you reach 90 degrees, here you reach 90 degrees, isn't it? So this is your y-axis, isn't it? This y-axis, I'm going to call this as theta is equal to 5. This is your x-axis, positive x-axis. So plus x, we are going to call this as theta is equal to 0. It's the same thing. You're not doing different things, only the names have changed. Now here, you've got minus x-axis. This I'm going to call this as theta is equal to 5. Because my polar coordinates has to go around the pole, facing the angle. Make sense? Here, I have got minus y. This we are going to name it as theta is equal to either minus 5 by 2 or yeah, 5 by 10. 3 by 2. Yeah. Now, so what we basically here is, we need to have a pole which is, no, why I'm telling x and y, because you need to have the relation as well. So the same thing we are having, but instead of having the x coordinate and y coordinate, the distance from origin, we are having angle and the value of r. Any questions? Yeah. You have to tell me when it is correct or not, or good or bad or whatever, or any question that come to your mind.
So instead of the x and y axis, you call it r and x theta?
Alright.
Or sorry?
Yeah, correct, right.
Oh, okay. So r is the x-axis and y is the theta.
No. To plot the point, supposing here, okay, let us think about, I want to make a point and try. What do? I take draw this E, so that is my R theta. This is my R. This is the pole. Because basically your polar coordinate starts with the pole and the initial line. Then what I will do, I'll put the protractor there, I'll make the angle 45, this is 3, and this point what I get here, this point I will name T, 5. Right? make sense? I'm waiting, guys. It's not same as x and y, isn't it? And we have to establish the relation between x, y, and theta.
Okay.
No, don't force yourself to say okay.
Yeah.
What about others? Are you all guys okay with this?
Okay, doctor.
Yes.
Now what I want now is that you have to measure the angle in anti-clockwise direction to get it positive. If you go reverse order, your angle will be negative. Now supposing we want to make a point P, let us say 3 only, and minus pi by 6. How will we draw it? You have to tell me, then I will draw it. Yeah? How do we make that point? Yeah? How do you want to start? Tell me, I'll start.
Question. What was the question?
I want to draw with point P3 minus 5 by 6. Just now we have drawn P3 5 by 4, isn't it?
P3 pi by 6, is it?
Your voice is very low. Can you just check your volume? I don't know whether it is problem from here or from your side.
What point are we supposed to draw?
We want to draw the polar coordinate of the point 3 minus pi by 6. I want you to tell me how do we draw it. Or you can send the image on WhatsApp. In the group also is fine. It's a very simple thing. Because you see that you need to have your concept correct, right? Did somebody send something? You can draw and send me, or you can tell me, I'll start drawing. Is there nobody who can tell me how to draw it?
The angle will be pi by 6, right? So you draw in like quadrant 1 and the clock
Minus 5 by 6.
yeah, minus 5 by 6 below the horizontal.
At the fourth quadrant.
Yeah, fourth quadrant. Minus 5 by 6. Wait, minus 5 by 6.
Isn't it minus pi by 6?
So this is your point.
Minus pi by 6, right?
Yeah.
Yeah.
So quadrant 4.
Quadrant 4. So do we need the value of x and y? No, isn't it?
No.
No.
So this is how the polar coordinates are. We will write down the value of r and theta. R is the length. That is why he was calling it as radius vector also. Length of the line or length of the point from the origin, and it revolves with the given angle, which is minus pi by 6 here. Does it make sense?
Yeah. Yeah.
Yes.
So let us suggest we've got another 5 minutes to go. Anyway, so guys, are you all okay? I'll just start the relationship in between x and y and r and theta. So that will be for today. Then we've got free time to do whatever extra practice questions from the. So you're going to have a test next week, right? Did I tell you about the next week test or no?
Yes, 11 August, right?
The test is on
11 of August.
your topics.
Summation of series and proof by induction.
So we're talking more relation between partition and polar. So what
Doctor,
is it?
can we have the test on Thursday?
Sorry?
Can we have the test on Thursday, like 13th of August? Because 11th of August is like the result day.
Even I
Yeah.
can't hear you properly. Yeah, what is that? Can somebody tell it a bit loudly who can hear him?
Can we have the test on Thursday because 11th of August is results day?
Oh, yes.
Yeah.
Oh. Wow.
Yeah, it's okay. Thursday. Just,
Alright.
just can you just remind me, or I'll note it down, but this is better to remind me so that I get the test paper ready. Thursday, and the other class can have it on Wednesday, I think. Yeah.
Okay.
Wednesday. The result is on Wednesday, right?
Results on Tuesday.
Tuesday. Okay.
Yeah.
So here, that should be fine. So here what I'm doing is, I'm not writing initial line or whatever. I'm just writing this. As I just now told you, this is M, this is O, this is X, this is Y. Now this one I'm taking as, now I'm using this as R, and this is theta, so that I have 30. So the same point I'm writing is R. Now you see here, we can write down x is equal to R cos theta. Is this okay?
Yeah. Yeah.
And y is equal to
R sin theta.
R sin theta.
Yeah.
That means here, if you know R and theta, you can write down the value of y and you can write down the value of x. Yeah? This is 2 into Cartesian. So if polar coordinates are given, you want to change it to Cartesian, then you will do it. Now since we have got this, can we write down x square plus y square equal to, what do you get?
R square.
That would be r square cos square theta plus r square sin square theta, right? This is simply like what you have been in. Because cos square theta plus sin square theta will be 1. Correct? Yes or no?
Yes.
Yeah.
So therefore, r is equal to square root square plus y square, and r is always greater than. This is something which will always remember. Now, since we got this, so now what you can do is r is, now again what I am using is theta is equal to y by r, right? Which we can write as x by x square plus y square square root sin theta y divided by square plus. Now this tells you, so these are the very important relations. You've got r, so this the last the p, this one now this is to change to. So when you got the here, this one, we got the value of x and y, we can change it to sin theta or cos theta, and we can get from this, we can get the value of theta, isn't it? X square plus y square, this is going to give you the volume part. So this is the relationship which is to polar coordinate. So this relationship is very important for us to use it. I think that should be all for today because we just got the new concept.